So today we're going to look at some special pairs of angles. So it's mostly terminology. You do have to have these words memorized. You have to know what the word means. I'm not going to ask you to quote the definition, but you need to know what it says. Okay? And you need to know all the terms. So the first one, adjacent angles. Adjacent angles are two angles that have the same vertex and they share a side, but they don't share any interior points. That's a really complicated way to say they're right next to each other. Okay? It's a little bit like if you've ever been, well, just in this room, right? Mr. Bauer's room. We share a wall, right? His room is adjacent to mine. Across the hall, Mrs. Jones's room, that's not adjacent to my room because we don't share a wall. So here, if I look at angle QRS, you don't need to do this, but I'm going to shade it in real quick. Don't worry about doing this, but if I shade QRS, and then I shade in SRT's interior, see how those are right next to each other? They share that wall, they share that ray. That's adjacent. As opposed to, let me show you this one. This one also starts with QRS, but then it talks about QRT. So from Q all the way around to T is this angle. Are those next to each other? No, those overlap each other. That would be like if Mr. Bauer's room was partly inside of my room. Okay, that's not adjacent. To be adjacent, they have to share a wall in between them. They have to have a side that they share and their interiors can't overlap. All right. Some other terms that you have used before in previous math classes. First one, complementary angles. Now, unfortunately, I find that a lot of students, when I say, what are complementary angles? They say, that means 90. Well, that's only partially true. And in math, if something's partially true, it's all wrong. Okay? Just like in real life, if something's partially true, it's not really true. Isaac, you all right? All right. So complementary angles has to be two angles. Can't be 3, can't be 7, it has to be 2. Whose measures have a sum of 90. It's not that each one of them is 90. Together, when you add their measures, you get 90. Each angle is called the complement of the other. Right, Garrett? Let's see if we can keep those eyes open. And facing up this direction. See if we can do both those things at once. Thanks. So, complementary angles can look like this. And a lot of times when textbooks introduce them, they draw these and they say those are complementary, which makes students think that they have to be next to each other. That's not true. Here, 1 and 2 are also adjacent. So let's add that. Angle 1, everyone's writing, and angle 2 are adjacent. They share that wall. They're right next to each other. Here, how do I know that A is the complement of B? Because 27 plus 63 is equal to 90. These are not adjacent. So if two angles are complementary, they don't need to be adjacent. They don't need to be next to each other. Their measures just have to add up to 90. So here's an example. If angle ABC and angle RST are complementary, the measure of ABC is 6x plus 23 degrees, and the measure of RST is 4x plus 17 degrees. Find the measure of angle ABC. Well, when it says that they're complementary, you need to know that we're going to add two things and set them equal to 90 every single time. If they're complementary, we're going to add two things, set them equal to 90. So this is 6x plus 23 is equal to 4x plus 4x plus 17 is equal to 90. Go ahead and work on solving that. All right, hopefully you ended up with x is 5, so the measure of the angle that they asked for, angle ABC, is 53 degrees. Are there any questions about that? We're good? All right, let's go on to the next one. Supplementary angles, on the other hand, are two angles that have measures that add up to be equal to 180 degrees. Occasionally I have a student who asks, Mr. Davis, I have trouble remembering which one is which. They say, how can I remember that complementary is 90 and supplementary is 180? Well, I think there are two ways that I think make sense. Which is first alphabetically? C. So it's smaller. Okay? Actually, there's three ways. The other way is that if you think about, and I think this is what you were doing, the supplementary is like two C's put together. The S. The other thing is, how many P's are there in complementary? You can look back at the other page if you need to look. There's one. How many P's are there in supplementary? 2. Supplementary is twice as big. Any way you need to help you remember which one is which. Again, they can be adjacent. Here, angle 1 and angle 2 are adjacent. And their measures add up to 180. And we can either say angle 1 and angle 2 are supplementary, or we can say angle 1 is the supplement of angle 2, or angle 2 is the supplement of angle 1. It means the same thing. And here, just like on the previous page, why are these supplementary? Because 130 plus 50 is equal to 180. And again, these are not adjacent. Just like with complementary, you need to know that the two angles add together to be 180. So for this problem, it says the measure of angle JKT is 43. Find the measure of its supplement. Well, that means I'm going to be adding two things and setting them equal to 180. So one of the angles is 43. I want to find the measure of its supplement. If you want to be boring, you can call it x. But when you get further in math, we don't call everything we don't know x. So I call it s. Now, if your s looks a lot like a 5, that may not be a good idea for you. I know some people, their s's and 5s look almost identical. So we just subtract 43 from both sides. And we get that the supplement is 137 degrees. All right. So here, they tell me these two angles, WXY and YXZ, are supplementary. Then give me the measure of each one of them and ask for the measure of the first one. Anytime you see supplementary, that means we're going to add two things together and set them equal to 180. So 6x plus 23 plus 3x plus 4 is equal to 180. So it's going to be 9x plus 27 is 180. Subtract 27 from both sides. You get 9x is 153. So x is, what is that? That's 90, so that's 63. X is 17. So then the measure of angle WXY is going to be 6 times 17 plus 23. Let's see, that's 60 and 42 is 102. Plus 23 is 125 degrees. So adjacent, next to each other, just like my room and Mr. Bauer's room, they share a wall. Complementary and supplementary, you've done that before, that should be review. Now some new terms. A linear pair of angles. A linear pair of angles are two adjacent angles, so they have to be right next to each other, whose non-shared sides form a line. So here, angle JXK, and I'm going to, you don't need to do this, but I'm going to show you, here's the interior of that. And then KXL, here's the interior of that. See how it's everything on one side of a line? I've shaded everything above this line. That's what a linear pair always looks like. They have to be adjacent, they have to share a side, and they have to be everything on one side of a line. Both those things have to be true for them to be a linear pair. Now, sometimes you may wonder, well, how important are linear pairs? We'll use them all year. And sometime in May, I'm going to remind you of this conversation. I'll say, remember back in September when I said we'll use linear pairs for the rest of the year? We will. We'll use it a bunch. Now, what else do we know about these two angles? Think about that for just a second. What's the measure of angle JXL, this straight angle? 180. So what do these two angles measures add up to? 180. So they are what kind of angles? They're supplementary. Turns out that linear pairs are always supplementary. But not all supplementary angles are linear pairs. It only works in one direction. All right, the other kind that we're going to use all year long are vertical angles. This will be a new term for you as well. Vertical angles are two non-adjacent angles formed by two intersecting lines. So if you just draw an X, the angles that are not adjacent to each other are vertical angles. Angle 1 and angle 3 are vertical angles, and angles 2 and 4 are also vertical angles. What type of angles are angles 1 and 2? They're not vertical angles. What type of angles are 1 and 2? Yes. They are indeed. They are a linear pair. Thank you. They're adjacent to one another, and they're everything on one side of a line. Are there others like these? Yes. I'll take a volunteer to tell me another linear pair in this diagram other than angle 1 and 2. 3 and 4? Yes, sir. There are other ones. Someone else want to volunteer to give me another one? Yes. Yes. Angle 2 and angle 3. And there's one more. Yes, ma'am. Yes, indeed. Angle 1 and angle 4. Those are all linear pairs. We'll talk more about it later, but linear pairs are always going to be supplementary. We're going to use that over and over and over and over again this year. So it's important that you can see them in a diagram. All right, so we're going to use this diagram now. We want to name each pair of vertical angles. So I'm going to give you one of them, and I want you to find the next one. One pair of vertical angles are angle QXR and angle TXS. Everyone see if you can find the next one if you have not already. Check with some of your neighbors. Don't let your neighbor be wrong. Geo, you've got that? All right, tell me the other pair, please, sir. QXT and RXS, perfect. Those are vertical angles. We'll talk more about this later, but what looks like is true about the size of these two angles? They look the same, and in fact they are. Okay, well, we haven't finished the last one yet. All right, so now let's do linear pairs. There are 4 linear pairs. I'll give you one. QXT and angle TXS. Question? Oh, yeah, let's let everybody catch up to you. Oh, well, there's the bell. Your assignment today is in the book. Oh, hang on just a second. Wait just a second. Oh, yes. Sorry, I looked at Thursday. Yeah, tonight's assignment's in the book. Yes.
I'll turn all the work tomorrow, and can I take like the test after school tomorrow?
After school tomorrow, yes.
Okay,
That would be great.